Hello friends, as we know, physics is a science which studies the nature and natural phenomena. And for studying natural phenomena, we require force. Force is a fundamental quantity which helps us in studying various natural phenomena. So we are going to start with the fundamental forces in nature. There are four fundamental forces in nature. The first one is the gravitational force. You must have learned about gravitational force in class 9th. It is basically the force of mutual attraction by any two objects by virtue of their mass. You must have studied Newton's law of gravitation, which states that if two bodies have some mass, then they will attract each other with a force which is known as gravitational force. And according to the Newton's law of gravitation, the force of gravitation is given by F is equal to G m1 m2 by d square, where G is a universal gravitational constant. m1 and m2 are the mass of the two objects which are exerting gravitational force, whereas the d is the distance between the two bodies. The second force which we are going to learn is the weak nuclear force. These forces were discovered during the study of phenomena of beta decay in radioactivity. Radioactivity you will learn in class 12th. It is a phenomenon which occurs in the atoms. Beta decay mostly occurs when a neutron in nucleus is converted into proton and electron. Whenever a neutron breaks down into a proton and electron, a beta particle is emitted out. This phenomena is known as beta decay. So second force is weak nuclear force. The third force which we are going to study is the electromagnetic force. These forces are between charged particles, and when the charged particles are at rest, this force is known as electrostatic force. You're going to learn about this force in detail in class 12. Now, the force of electromagnetic is given by F is equal to K Q1 Q2 by d square. This formula was found out by using Coulomb's law, where K is a Coulomb's constant and Q1 Q2 are the charge of the object, whereas D is the distance between the two charges. The last force which we are going to study is the strong nuclear force. This is a force which binds the neutron and proton inside the nucleus. If we consider the ratio of all the four forces or all the four fundamental forces, then we can see that the gravitational force is the weakest force in nature, whereas the strong nuclear force is the strongest force in nature. The electromagnetic force is of much importance for us. The tension in the spring, the friction, and all these forces can be explained with the help of electromagnetic forces. When two bodies rub against each other, then some charge is transferred from one body to another. This results in the force of friction and other forces. So electromagnetic force is a very important force which is studied in different forms in the upcoming chapters. Now you must have heard of word measurement. What basically measurement is. First we'll study what basically are quantities. Quantities are such things which can be measured and is very helpful for us in understanding various laws which governs the nature. For example, force is a quantity. So we need to measure force. Only then we can come to a certain conclusion. So measurement is a very important phenomena. And what was the need of measurement? So physics, as we know, is a branch of science which deals with the study of nature and natural phenomena. So for a precise description of any such phenomena, measurement of the quantity is essential. Quantity means force, mass, length, time, and many more. So for a precise description of these quantities, measurement is very important. Now various quantities were derived and were used for studying various natural phenomena. And along with the quantities, we require a unit which gives a proper description of the quantity. For example, if I write F is equal to 5, then what does this indicate? It only indicates that F is a variable whose value is equal to 5. But at the same time, if I write F is equal to 5 Newton, then what does this Newton indicate? The Newton indicates that F denotes force. So N or Newton is the unit which gives complete description of the quantities which are being studied in physics. So first we'll study the fundamental quantities, and along with that we'll study the fundamental units which are related to these fundamental quantities. Now there are basically 7 fundamental quantities, and those quantities are length, mass, time, temperature, electric current, luminous intensity, and quantity of matter. These are the fundamental quantities using which we can derive some complex quantities as well. For example, as I discussed force. Force is a complex quantity and it is derived with the help of mass, length and time. So mass, length and time becomes the fundamental quantities, whereas the derived quantities are force, velocity, speed, acceleration and so on. So there are 7 fundamental quantities: length, mass, time, temperature, electric current, luminous intensity and quantity of matter. You must have studied about length, mass, time, temperature, current and even quantity of matter. But for you, luminous intensity is a new quantity. So what basically luminous intensity is? Luminous intensity just help us in finding out the amount of light energy radiated, and it is defined as the amount of light radiated in a unit time per unit solid angle. Solid angle, it means if I take a 3D body and a certain amount of light is coming out through it at an angle in a given time, then that quantity will be known as luminous intensity. So these are the 7 fundamental quantities. Now let's study the 7 fundamental units. For length, the unit is meter. For mass, it is kilogram. For time, it is second. For temperature, it is Kelvin. Please remember this: the fundamental unit of temperature is not Celsius or Fahrenheit, it is Kelvin. So whenever some scientific studies are done, the temperature is always calculated or measured in Kelvin. Next is electric current. You must have learned this in class 10, that the unit is ampere. For luminous intensity, it is candela. And for quantity of matter, it is mole. You must have studied mole concept in class 9. So for the quantity of matter, it is mole. Now there are some supplementary units also, which helps these fundamental units in finding out derived units. There are 2 supplementary units, or first let's study there are 2 supplementary quantities: plane angle, that is angle in 2D, solid angle, that is angle in 3D. For plane angle, the unit is radian, and for solid angle, the unit is steradian. Once the quantities were discussed, a system of units was defined. So there is a uniformity throughout the world. Many systems were taken into consideration, and finally nowadays we are using the International System of Units, which is known as SI unit. But there were other systems also which were used earlier. The first one is the FPS system. FPS system. In FPS system, the length was measured in foot, the mass was measured in pound, whereas the time was measured in second. This system was commonly used in the United Kingdoms. The second system which came into effect was the CGS system. In this, the length was measured into centimeter, the mass was measured into gram, and the time was measured in second. So after some time, a new system was again derived. It was known as the MKS system, in which the length is measured in meter, mass in kilogram, whereas time in second. So what was the need of so many systems? So the first system, that is the FPS system, was not used because of inconvenient multiples and submultiples. It means if the mass was given in gram and we need to convert it into foot, then the conversion factor was very difficult to remember. So after some time, the FPS system was neglected. Then the CJ system. In this, the derived units were inconveniently small. See, if we need to derive Newton, in this, if we use the length as centimeter, then it is very difficult for deriving new units. So because of this, the CJ system was not taken into consideration. Finally, the system which we use is International System Unit. It is basically the modified version of MKS, and hence It is also known as rationalized MKS system. In this, mass is taken in the form of kilogram, length meter, whereas time is measured in seconds. Now let us study some important practical units. Now what is the need of practical unit? See, if you need to find out the distance between Earth and the Sun, then in kilometer you will get a very large value. So it is very difficult to write and remember that. So for measuring very large distances, some practical units were derived. So we'll study those practical units. The first one of them is the astronomical unit. It is basically the average distance of the center of the Sun from the center of the Earth. Whatever that distance was, it was taken to be one astronomical unit. In meter, it is almost equal to 1.5 into 10 to the power 11 meter. It means we can say that one astronomical unit is equal to or almost equal to 1.5 into 10 to the power 11 meter. So if some celestial body is even far from the Sun, it is convenient to write their distance in the form of astronomical unit. The second which we are going to study is the light year. It is basically distance traveled by light in vacuum in 1 year. The distance traveled by light in 1 year will be equal to 1 light year, and which is equal to 9.46 into 10 raised to the power 15 meter. So 1 light year is equal to 9.46 into 10 raised to the power 15 meter, and light year is indicated by Ly. The next which we are going to study is parsec. Now what basically parsec is? So let us understand it with the help of the diagram. A and B are 2 points and there is an arc. If the length of this arc is 1 astronomical unit and it subtends an angle of 1 second at point O. I will repeat it again. The length of the arc is 1 astronomical unit, which is equal to 1.5 into 10 raised to the power 11 meter, and it subtends an angle of 1 second at a point O, then the radius will be equal to 1 parsec. So the definition of parsec becomes 1 parsec is the radius of a circle at a center of which an arc 1 astronomical unit long subtends an angle of 1 second. And on calculation it is found out that 1 parsec is equal to 3.1 into 10 to the power 16 meter. So these are some of the practical units which are very helpful in finding out large distances. Next we are going to study about indirect methods of measurement of large distances. What is the meaning of indirect method? So direct method is basically, let's say for example, if I need to find out the length of this pen, and what will I do is I will take a meter scale and measure its length. So this will be a direct method. And what is indirect method? You must have learned in class 10th about trigonometric ratios. For example, if I need to find out the height of this tower and I am standing at this distance, so if I draw this line, I can find out this angle. If I move to some distance towards the tower and again subtend an angle, I will get this. So let this distance is x and this is y, and the height of the tower is h. So by using trigonometric ratios you can find out this h, and this is known as indirect method, as you are not directly measuring the length, you are just finding it out with the help of some mathematical ratios and some calculation. So this is known as indirect method. So we'll use indirect method for measuring large distances. And the most important or most commonly used method is the parallax method. Now what basically parallax is? For this, let us do a small experiment. This experiment has to be done by you students. I will explain the experiment. Keep your index finger in front of your left eye and close the right eye and try to see the finger. Next step will be keep the finger at the same position, close your left eye and open your right eye, and then try to see the finger. What will you observe? You will observe that the position of the finger slightly changes. For example, if the finger was initially at this position and you were seeing it with the help of left eye, keeping your right eye closed, this was the position. Now if you close your left eye and see it through the right eye, you might see the pen at some distance or at some position over here. So you will notice that there is a shift in the position of the finger. Now why does this happen? It happens because in between your two eyes there is some distance. Now what basically happens is, let's say for example your finger was over here. You are seeing it with the help of left eye. Then this was the angle subtended. In the second case, when you were seeing it with the right eye, the object was at the same place, then this was the angle subtended. In the both cases, the angle subtended differed, so the position of the finger also differed. This is basically what parallax is. Now we will use this phenomena to find out large distances, such as distance of planet or a star from the earth. And what is the basic concept used? The basic concept used is, we have studied that angle is equal to arc upon radius. For example, there are two observatories on earth. First it is A and second is at B, and O is a planet, let's say, which is at a distance D. If we see from the first observatory, this is the distance D, and second case if you see from the observatory B, this will be the distance. Let's say this is the the angle which is subtended, and AB is the distance between the two observatories which is known to us. So we can say that in this case angle is equal to arc upon radius. If this distance D is very much greater than L, then this L will be considered as the arc. So angle is equal to arc upon radius. So theta is equal to L upon D. Therefore D will be equal to L upon theta. So using this we can find out the distance of this planet O from any observatory, either A or B. Now how to use this parallax method? Let's say we need to find out the position of this planet P, which is at a distance of AP or BP from the earth. Initially earth was at point B. This curve is the earth's orbit, and this AB is the diameter of the earth orbit which is known to us. For using parallax method, we need a very far off star और a planet. हमें एक ऐसा planet और star चाहिए जो बहुत दूर हो. अब since it is very far, the angle subtended by this star or planet at this point will not change. How? Let's take an example. If you are moving in a train and if you see the sun, and after let's say half an hour or hour, if you again look at the sun, it appears to be at the same position. And why does this happen? It happens because the sun is very far from us, and the angle subtended by the sun on our eye doesn't change much. So for using parallax method, we need a star or a planet which is very far away from us, so we can say that its position will not change with respect to earth. So initially let us say earth was at point B. The angle subtended, as you can see, the angle FPB is theta 2. This angle can be found out with the help of astronomical telescope. What we'll do is we'll first keep our focus of the telescope towards the star F, and then we'll slightly shift it towards the star or planet whose position is need to be find out. So we can find out the angle. Let's say this angle is theta 2. So by geometry this angle will become theta 2. Similarly, let's say after some time the earth came to position A. As the star F was very far away from us, its position will not change with respect to earth, as we have discussed in the case of the train and the sun. So again we'll keep our telescope, astronomical telescope, along F, and then we'll tilt it so that we can see this planet F. So this angle will be theta 1. As per geometry, if this is theta 1, it will be also theta 1. So as you can see, there is a small portion made PAB, where AB is the diameter of the Earth's orbit, and it is known to us. So using the formula, angle is equal to arc upon radius, where the diameter would become the arc, and the angle theta 1 theta 2 can be found out using astronomical telescope. We can find out the distance AP, or you can say BP. So using this we can find out the distance of a certain planet or a star which is very far away from the Earth. But there are some limitations also. And the limitations for parallax method is it can be used for measuring distance which are less than 100 light years. If the distance is more than 100 light years, then the results are not so accurate. Thank you students for listening patiently.